Hi friends, the next issue to look at is about the page sharing. Most often we come across with tools like a text editor or a video player, music player and so on, where one text editor is used to create multiple texts. Then if one text editor like Windows Word is being used to create multiple documents or Word documents, then one option is to load the Word tool for each document. But we know that the Word tool has the same code whether you open it once or 10 times, doesn't make difference, but yes, it is going to consume the space. The 10 copies of MS Word put on the main memory is only going to consume the space, nothing more than that. But yes, it is going to degrade our efficiency. It is going to be a big problem when it comes to the memory utilization, efficiency and all that. On the other side, being a uniprocessor system, anytime only one process will be working. That means any given time only one MS Word document will be being used by the processor, or the processor will be processing any one of the MS Word documents. That means any given time only one MS Word code will be running, though there are 10 copies of MS Word codes. So instead of that, if we can have only one copy of the MS Word and have different documents, that is the data, as a separate one. So in that case, what we can have is we can share the resources, because these resources are put in the form of page, and if we can share these pages among the processes, then we can save a lot of memory, and at the same time there won't be any degradation in the system efficiency. So let's look at how the things are doing. So see that there are three processes, P1, P2 and P3, and P1 is working with editor 1, editor 2, editor 3, and P2 is working with editor 1, editor 2, editor 3, and same case with P3, editor 1, editor 2, editor 3, all three are being used. P1 has got a page like a data 1, P2 has its own data, data 2, and P3 has its own data, data 3. Now what is happening is one option is this ED1, we should have 3 copies, ED2 we should have 3 copies, ED3 we should have 3 copies, one for each process. But instead of having 3 copies of each, we could have only 1 copy of each. So ED1 1 copy, editor 2 1 copy, editor 3 1 copy. And how we can use it? Yes, we can use it through the page table. Editor 1 is located at frame 3, editor 2 is in frame 4, editor 3 is in frame 6, data 1 is in frame 1, data 3 is in frame 2, data 2 is in frame 7. So accordingly, if we match the page table, so editor 1 we want, so that is there in frame 3, editor 2 is in frame 4, editor 3 is in editor 3 is in frame 6, and data 1 is in frame 1. That is for process 1. For process 2, editor 1 is in frame 3, editor 2 is in frame 4, editor 3 is in frame 6, and data 2 is in frame 7. So this 3, 4, 6, 3, 4, 6, 3, 4, 6 are common, because editor 1, editor 2, editor 3, editor 1, editor 2, editor 3, editor 1, editor 2, editor 3 are all same in sequence. Therefore 3, 4, 6, 3, 4, 6, 3, 4, 6 we can write. So whenever we want to use editor 1, it goes to frame 3. Whenever we want to use editor 2, it goes to frame 4. Whenever we want to use editor 3, it goes to frame 6, whether it is done by process 1 or process 2 or process 3. Only difference is if process 1 is working, then it works only with data 1, and if process 2 is working, it works with data 2, that is in frame 7, and if process 3 is working, then it will work with the data 3, which is there in frame 2. So this way, by properly mapping the page table, we can allow page sharing, and because of this, we could reduce multiplicity of the codes on the main memory, and thereby we can reduce the unnecessary usage of the memory, and redundant usage of memory can be avoided, and because of that, more memory is available for other processes, other data, and so on, and therefore we can increase the utility factor of our memory through what we call page sharing. So that's it about the page sharing. Thank you.